So here we're looking at a proof by induction question. It's a series question, and the question actually comes in sigma notation. Okay, so this letter here is a capital sigma, and what it tells us is that this is a series. Okay, this is what the start of my series is at, and this is the end of my series. So what you end up doing is you sub in the first, or the starting, the n for the starting point. So sub in one here, you'd get 1 bracket 1 plus 1, so it'd be 1 by 2. And it's a series, so we're adding on, and then you add on what would be if you'd sub in 2. So the next number along. So it would be 2 bracket 3. And the next one, if n was 3, it would be 3 bracket 4. And we do dot 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 to signify that it continues until the end point. And we're ending when it is n. And this equals to what is over here. N over 3, n plus 1, n plus 2. So we want to prove this using proof by induction. So again, we're quickly doing step 1. Prove true for smallest allowable n. So in this case, that would be n is 1. So we're getting 1 bracket 2 is equal to, subbing in 1 over here, a third. This would be 1 plus 1 is 2. This would be 1 plus 2, which is 3. 2 is equal to a third of 6. That's a third of 6. 2 is equal to 2. Therefore, true for n is equal to 1. So step 2 then. Assume true for n is equal to k. Might actually just use a smaller pen. How do we do that? Well, anywhere back up here in our series, we are removing the n and we're subbing in k. So as far as I'm concerned, this is true. Step 3 then. Step 3 is to prove true for n is equal to k plus 1. So here we are going to write it out, and anywhere where there was an n, replace it with a k plus 1. And I'm going to leave a little gap here. And it was n. So this is k plus 1, and this is going to be k plus 1 plus 1, which is k plus 2. So k plus 1, k plus 2. On the right hand side, if you go back, you'll find that it would be k plus 1 over 3. K plus 1 over 3. Here I'd have k plus 1 plus 1, which would be k plus 2. And this would be k plus 1 plus 2, which would be k plus 3. And I've left a little bit of a gap because this is my first term, my second term, my third term, and this is my k plus 1th term. Well, what was this up here? This was when n is equal to k. So this is my first, second, third, and kth term. Well, what comes before the k plus 1th term? Well, the k term. So this is k plus 1. This is my kth term. And I now use my assumption. I notice that this whole left hand side where the dot 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 is equal to what I have up here. So I can replace it with this here. So I have k over 3, k plus 1, k plus 2, plus k plus 1, k plus 2 is equal to k plus 1 over 3. And now I'm starting to think, what do I not like? Well, for me, it's generally fractions that I don't like. So I want to show that the left-hand side is equal to the right-hand side. So how am I getting rid of this fraction here and this fraction here? Well, I can multiply everything by 3. In doing that, multiplying this by 3, I'm getting rid of the fraction. So I'm just k plus 1, k plus 2, plus I need to multiply this by 3. Multiply all of this by 3, I'll just get rid of the fraction. So I've just gone and multiplied out from the left-hand side to the right-hand side to speed us up a little bit. So coming from here to here, I multiplied everything by 3. So all of this getting multiplied by 3 gets rid of the fraction. This gets multiplied by 3. And this gets multiplied by 3 to get rid of the fraction. Multiply it out, being really careful. And you should find at the end that you get left is equal to right. So make sure to complete it by writing out your final step. So we're saying therefore true for n is equal to k plus 1, assuming true for n is equal to k. We know it's true for n is equal to 1 was the very first thing, and then we reiterate our statement from the very start. The sigma starting at n is equal to 1, ending at n of n plus 1 is equal to n over 3 by n plus 1 by n plus 2. And it doesn't say n is greater than or equal to 1, n is an element of n, but I think it probably would if it was an exam question. So to reiterate, when you have sigma notation, the very first thing you should do is rewrite this left-hand side as a series. Sigma is just another way of saying series. Hopefully that helped you out.